Today's video topic is all about writing procedures. You're going to have a lot of opportunities in science class to write procedures for experiments that you create and come up with. And procedures are really important to the whole process because a procedure is a way to help validate your learning and understanding, because at the bottom line of all things, the reason that scientists write procedures is to know exactly what they did and to be able to go back and redo that if they needed to, or give it to someone else to complete in the exact same way that they did. And so if you're not exact and precise with your procedure writing, it's going to be difficult for people to repeat the things that you have done. And so I'm going to give you a few tips today about some things that I'm going to be looking for when you have different opportunities throughout the year to write procedures so that you can have a leg up this whole year in science class. Sound good? Let's dive in and check it out. So what I've got here is actually a rubric that I use whenever we are doing a full inquiry experiment from start to end. This is my go-to rubric. And so I really want to make sure that you're familiar with it and that you understand the expectations that I have. So let's take a look at just procedures, since that's what the video is about today. Let me make it a little bit larger for you so that you can see the expectations. The first thing that I want to talk to you about is this first part in the high column, and it says that procedures are listed in clear steps, okay? And that is a biggie, okay? Listed in clear steps. You want to make sure that when you're writing things out in a procedure, that it makes sense, that people know what you're talking about, that it doesn't just say get a glass. Because if you say get a glass, you could be getting a Flintstone glass with juice in it, or you could be getting an actual beaker glass. Okay? Two very different types of glasses, but if you're not specific about it, how are we supposed to know? So you want to make sure that they are clear steps. You don't want to get too wordy with your experiment procedure steps. You want to make sure that you're just wordy enough. So it's kind of like the Goldilocks effect. Too wordy over here, not so wordy over here. We want to be right in the middle so that we know exactly what it is that you are trying to do in your experiment. With that, you want to make sure that those things are clear. I could say get some distilled water. Okay? Is that a step? Is it clear? Sure, it's a step, it's cleared. But what if I wanted refrigerated distilled water? But that wasn't in there. But I just said get distilled water, and you're like, oh, okay, here's some room temperature. Would I get different results? I don't know. But it is something that could be different if I was using refrigerated distilled water and someone else was just using regular old distilled water at room temperature. Okay? So those are things to keep in mind and keep in the front of your head. You also want to make sure that you are specific with details, but don't get into that too wordy column, okay? We want to make sure that we say things like measure 50 milliliters of refrigerated distilled water. That's a very specific step, but that doesn't say measure 50 milliliters of distilled water from the refrigerator in the FCS room at Mid Prairie Middle School. See the difference? I got into the too wordy column. Okay. You want to make sure that you hit that middle, the Goldilocks column, the just right between too wordy and not so wordy. You with me? All right, let's dive into our next step. The next step is that you have numbered steps. Okay. I have totally seen students turn in procedures that just have a big chunk of words, and they say that that's their procedure. But how am I supposed to understand when there's literally no capital letters, no numbers separating out the numbered steps, and no punctuation? Literally just lines and words. I have received that from 8th graders before, so don't be that student. We want to make sure that we have a number with a period and then a sentence, capital letter, period at the end, of a short direction of what you are going to be doing in your experiment, or if someone else were to do your experiment, how they would have to complete the experiment. So make sure that you don't get tripped up on that. The last thing before I go into all of this is those two things in the procedure rubric. They are short, but they are so loaded. Okay, you really have to think through your procedure because this is your process. This is where you're telling people what it is that you're trying to accomplish in this experiment. You don't necessarily know what you're going to learn yet, but this is giving you the process that you're going to try to follow. And so with that, it's a really good idea to, after you've written your procedure, go back and reread the procedure. Maybe you can even fake do the experiment to see if there's anything that you've missed, or have somebody else read your experiment procedure before you hand it in or before you actually begin your experiment. Okay. The last thing though, before I go on to the very last part, is that it's all about your process. And I know that in science, processes change all the time. Okay. And so with that, I want you to know that your procedure is not locked in stone, okay, once you have completed your procedure. Because once you get into your experimental phase, things might not work out the way that you planned it to work out. And that happens. And it's okay. Failure is a part of science. But what you need to keep in mind is that if you change your process, then you need to go back to your procedure and change your procedure before you share any of your results with anyone else. It's a simple thing, but a lot of students might try to slack off with that, and so make sure that you are not one of them. Okay? The last thing on here is that diagrams needed to be included to describe the setup of your experiment. A diagram might look like this. All a diagram is a sketch or an image showing your setup. It's usually labeled, okay, to show all of the specific parts of it. You want to make sure that your diagram, all it is a visual component of what it is that you're doing. So that's another good check and balance to make sure that if someone else were to complete your experiment or if you were to redo your experiment, this helps people, especially visual learners, get an idea of what it is that you did and what your setup is. Your diagram could be a photo that you upload and then you draw labels to describe things. You could use an online computer program like Google Drawings, or you could use SketchUp to actually create the boxes and things on their own. Now, if you do something like that, that will take more time and you need to know that in advance. It is very important to take your time with your procedure, but don't take too long so that you actually miss out on some of the experimental time, because then that means that you might have to do some more things on your own outside of class. The diagram is a required component of 8th grade procedures, so you need to make sure that you work to complete that. And if you have any questions about it, feel free to ask. The bottom line is that it's essentially just a sketch. You can use fancy things like a computer program to help you for more important experiments like your science fair inquiry projects, but you don't always have to. You can just complete a sketch in your lab notebook and label it to create your diagram for some of our quicker experiments. So hopefully that gives you a good overview about what my expectations for procedures are, and that hopefully you can try to hit the Goldilocks zone with your procedures so that we have some strong work that we can see throughout the process of science that we're going to be practicing this year. Again, if you have any questions, please just let me know. Otherwise, we'll see you in class.